by Likhita, who is our AIML lead in GDAC Atria. So I would like to invite Likhita for the session, and yeah, this session is over to you, Likhita.
Hello, guys. Hello. A very good evening. And I hope you all are not really tired and can listen through the entire session. And please do make it a little interactive. Please don't keep it boring. And are you guys there on the other side? Or can we get some interaction? Okay. So let's get started. And if you guys have any questions, you can just raise your hand or drop a text in the meeting itself. So let's start off. So this is going to be the first workshop. There are going to be two workshops, and then this workshop you'll be learning machine learning, the basics of machine learning, and how the models work and everything, and then the basics of TensorFlow. So what is machine learning? Machine learning, it comes under artificial intelligence, and it basically uses your data sets, whatever data you've collected, and it's going to go through it, and it's going to learn from it, and it's going to find patterns through it, and it's going to predict what you want it to predict without being programmed. Like, you don't need to separately program it to do something. All you have to do is give it a data set, and it's going to go through the data set, it's going to learn, and it's going to come up with its own, basically, programming. So under machine learning, we are going to learn now, we are going to learn two kinds of machine learning algorithms. One is supervised and the other is unsupervised. So in supervised machine learning, what happens is you have data sets like, let me give you an example. Now you have a data set over here. This data set is of a flower called the iris flower. And
Likhita, I
yeah.
think there is a slide you are presenting, or nothing is there.
Oh, I'm not presenting. Okay, sorry. I'm
Yeah,
really sorry.
yeah.
I thought I selected it. Sorry.
No, no, chill.
Okay, you guys can see it now, right?
Yeah, it is visible. Yeah.
Okay, thank you. Sorry, guys. Okay, so in supervised machine learning, you have data sets like this. And as you can see, there are multiple columns in these data sets, right? And these multiple columns have a name, each have a name, and these are called labels. So this data set is a label data set. So this comes under supervised machine learning. But when these columns are not labeled and you don't know what each column is telling you in the data set, and you don't know basically anything in that data set, that's called your unsupervised machine learning algorithms. And under supervised, you have many other algorithms like linear regression, logistic regression, and support vector machines. Even neural networks come under supervised. And in unsupervised, you have k-means clustering, basically your clustering algorithms. And how exactly do models work? Your machine learning models work. So your machine learning models, when they are training, they pick a feature. feature as in this data set, your sepal length and your petal length, they are called features. Each column is like a feature. So based on each feature, these models train. So for example, over here in this single feature, the feature here is, does the house, here the machine is training to predict the price of a house. And in this model, the feature is whether the house has two bedrooms or not. If the house has two bedrooms, then it's going to predict the price as so much. But if it doesn't have two bedrooms, if it's less than two bedrooms, it's going to predict as so much. And in when you have multiple features, it basically creates its own kind of uh, tree. And it's like, if it has more than two bedrooms, and if the size of the house is so much, more than so much, it's going to predict the house rate as so much. And if it's not so much, it's going to predict the house rate as uh, so much. And so this is basically your multiple features. Based on one feature, if that's true or not, it's going to check for another feature. And based on that next feature, it's going to give you your predicted output. Now, for any basic machine learning problem, you have multiple steps to solve it. So the first step to solving a problem is to define the problem. You have to look at the problem, you have to look at the data set, and you have to clearly understand what it's telling you and what you need to find out. For example, in this flower ka data set, they've given you your sepal length, they've given you the sepal width, and the petal length and the petal width. And what you want the model to do with using this data set is you're training it to identify the species of the flower. So basically, here, using all of this data, you have to predict this, the last column of your data. So that's how you define your problem. You look at the data set and you look at your problem and you select what you need to train it with and what you need to predict. And you have to make sure the data you're collecting is right and it's relevant, and all the data is going to be used in the proper way. And pre-processing data, so you have to, all the data sets you get, it's not like you're either not going to use all the features or the features are not enough. So you have to clean, and sometimes there are even empty rows and columns which might give errors in your models. So the next step is to clean and format your data properly, which you have to like think and do it properly. And then the next step is to split the data. And in splitting the data, why exactly you split the data is because you have to have a separate set of data to train, and you have to have a separate set of data to test once the model is trained, to check if the model is giving the right answers or not. And then choosing a model. Machine learning has many different models, like I told before. Like, there is neural networks, there is regression models, there are classification models. So it depends upon you which model you choose, and you have to make sure the model you choose gives the least amount of error and is as accurate as possible. And then the next step is to train the model. All you have to do is, feed the data into the model and fit the data, and the model will be trained. And the next step is to evaluate the model. Evaluation is nothing but making sure your model is giving accurate and correct results. And this evaluation is just done based on your testing data. We had first separated the data into two, groups, right? Training and testing. And here is where we use the testing data to check if the performance, if it's performing well, and then deploying the model. After everything, once you have evaluated the model, you can deploy it in the real world and use your model. So defining and collection of data we went through is, let's get to pre-processing the data. So here we have a data set of the iris flower. And what this data set has is, it has the sepal length, it has the sepal width, it has the petal length, and has the petal width. And with the help of this, we have to predict the species of the flower. That is our goal with the machine learning model. So we went through the data, we saw what it has, and we have to check what are the relevant columns and relevant features that are going to be used in the model. For example, this ID column is there, right? This ID column is not exactly going to be of any help to the model. If we use the ID model, it might even increase the error percentage in our model. So what we have to do is we have to drop, or we have to delete that entire column from the entire data set. So for that, we are going to be using, you know, Python libraries such as pandas and NumPy and Matplotlib for, and Seaborn for visualization and stuff. And here we are dropping the ID column because it's not going to be of any use for us. We are going to be using this command df.drop. Here df is your data set, your data frame, and df.drop id is the name of the column. Axis is equal to 1 is basically you're telling it it's the column, and if you give axis as 0, it's the row, and axis is equal to column, and in place is equal to true is, it's going to delete the column from the data set where it's storing to. If you don't give in place is equal to true, it won't delete it in the actual data frame where it's storing. The info function is from pandas library, and it will give you all the information of all your columns and the data types, of each values. As you can see here, the sepal length, sepal width, petal width, all of these are in the float data type. Float is nothing but your numbers, but species has the object data type because object is nothing but your string over here. And one thing to keep in mind is that you can't fit a model with string values. You can't fit a model into any machine learning algorithm with string values, and you have to convert it into numbers or numericals. So this is an important step. You have to check whether any of your columns has any string values, and make sure all your columns have your numerical values. Hello guys, I'm not going too fast, right? You guys can understand.
Yeah, Likita. It is in a good pace. Other people, please like be more interactive with the session.
Guys, you can let me know if I'm going too fast or you didn't understand anything.
Yeah, I think you can carry on, Likita.
Okay. So as you can see, the species has the string data type, right? So when we can't fit the string data type into the machine learning model, and even in and then in this, it's gonna just describe the how many unique or how many unique values you have, and the minimum and the maximum values and the count of it, how many rows you have, and all of that. And then if you want to, you know, for visualization, when you want to check each graph or like values, or you just want the graph or of each of the columns and everything, you can use these df.plot. Here it's df.boxplot is giving you the box graph, and here it's giving you a normal plot, each column with their values. And it's just here it's this scatter plot, and this is just to visualize your data to understand it better. If you're not understanding your data and you want to understand it way better, this is how you do it. And here df.core, it's basically your correlation, the columns correlation with other columns, and this is the heat map of that correlation. And df.mean, it's just giving you the mean values of each of the column. Okay, leaving all that, now you have, sometimes what happens is, each sometimes a few of your rows or a few of your columns, they have either null values or they have no values at all, and you can't fit your data into your model when it's like that. So df.drop_na is a function from pandas that deletes any of your zero values or null values. And df.fill_na, if you have null values and you just want to replace it with some other number, you can give df.fill_na, and in brackets you can give a number that you want to fill it with. If let's say I give it, instead of zero I give one or two or three or whatever, and what it does is, instead of the null value, it's going to give that particular, it's going to fill that particular number instead of the null value in place of it. Now, like I told before, you can't fit a string value into the model, right? So when that happens, uh, when you have a string value, but you need that for your model, like it's a very important feature. What you have to do is, you have something called label encoder. What this label encoder does is, it takes each of your string value, how much of a string values it has, and it gives you each string name or whatever a number, a specific number just for that string. Like suppose you have this iris setosa, and in the end you have something called iris virginica. So this iris setosa might be 0, and iris virginica, it might give 1. So like that, it gives each of the string or each of the names its own number. And this is where you're importing it. You have a library called scikit-learn, and that's where you import it, and that's the library you use for this. So first you import your label encoder over here, and then you fit whatever. Here you have only the species as string, only your species is string. So you fit it into the label encoder, and you have a function called transform. So once you transform it, as you can see, it's given each of these a different numerical value. And then next you have the min max scalar. So in the minimum maximum scalar, what happens is when you have values ranging like in a wide range, like the difference is way too huge. So that's the time you need to use scalar, because when the difference between the minimum value and the maximum value is very high in the like in a feature or in a column, it kind of throws off the model and the accuracy becomes a little less. So what you have to do is in the min max scalar, it scales the values to a lesser proportion. Like um, for example, over here, the minimum maximum, the values were between like let's say 0 and 7, right? But the values over here, you can see it's become less than 1. So it becomes easier for the model to make connections, to find patterns, and the accuracy will be a little more. So that's where you use your min max scalar. I'll just go through another. I have another data set too. I'll just go through the same things again, but with the different data sets so you guys can understand better. So again, we need the same libraries from us. You have the matplotlib and the cbon. Here numpy is for your operations, even pandas is for your operations on the data sets, and matplotlib and cbon is basically for your data visualization, right? So using pandas, you first read your data set. For Okay, just a quick thing. You guys can do this either on your Jupyter notebook, like you have a Python IDE on your laptop. You can either do it on that, or even Colab is easier, I guess. And sometimes, and the thing is, when you download a data set, for you to get it here, you have to first upload your data set. I'm sorry I didn't tell that in the beginning. So to upload your data set, right? Just a minute. Because what happens in Colab is, since it's online, it can't really read. It can't really read. The data or the files on your computer. So you will have to first upload the files to Colab, and for that you have an option here. There's a file icon. You go there, and you either drag and drop, or you'll have an option to upload your file here. Okay, once it's uploaded, If you're using something which is already on your computer, like your Jupyter notebook or something, here you have to give the path that is stored. Like, for example, if you go here, you can copy as path and paste that path there, or you can just give the name of the file. Since you've already uploaded the file here, you can just give the name of the file since you're doing it on Colab. And this data set, so basically this data set is based on the salary of people, right, and other features. So here the target is the salary of the people. It's less than or equal to 50K or greater than 50K, and that is your target, and that is what you'll be finding out in this data set, using this data set, right? So if there are too many number of columns or something, you can just give the command okay, just a minute. Okay, so here the data is not labeled, right? The data is just given as zero. The column is just given as 0, 1, 2, 3, 4, 5. So here you can just rename the columns as df.columns equals, and you can just give the all the names in square brackets and name all your columns. And as you can see here, there are so many features. You have age, you have the work class, like where they are working in they have a government job, or are they in the private sector, or are they self-employed, and you have the education they've gone through, and then their marital status, their occupation, their relationship, the sex, are whether they are male, female, and which country they're from. And then you have finally their salaries. So here, when you give the info function, you can see that the work class, the education, marital status, and so many others have the object data type. The object data type, in the sense, the string data type. So for that, and there is also instead of float here, which is basically the same. You don't need to mind that since they are both numerical data types. And here, in the data set, you're dropping all the null row values. So if there are any rows which have no values, then you're dropping that. So, and that's the reason you're giving access as 0. If you give access as 1, you're dropping the columns, but if you're giving access as 0, you're dropping the rows. And as you can see, the number of rows has reduced over here after you've given the drop any rows. Here it was 32,000 rows, 32,500, and here you have 30,000 rows. So it's quite a number of change. It's dropped like around 2,000 rows, which had no values at all. And you have the correlation. And finally, the label encoder. So since you have number of columns which have the string data type, right? You have so many uh, columns with the string data type, and you can't do that one by one. So you're using a for loop here. So first you, from scikit-learn preprocessing, you import the label encoder, and then you fit each of them, and then you transform each of them with the label encoder. As you can see, now they're all in numerical values. There are no string values at all. And here, just making sure the columns, right? The columns which I've given here, these are all the columns that have the string values. So using this, you're going to use a for loop. So each column in the category of columns, you're going to use label encoder, and you're going to transform each column in this category of columns. And this category of columns contains the columns which has all the string values. And this was your pre-processing. This, you have to do all these processes before you train your model, and then you test your model, because you don't get pre-processed data on the net or anywhere, and it's your job to clean up the data and make sure uh, it fits the data models properly. And then the next step is to split the data. So splitting the data is basically you're dividing the data, the given data set, into two groups, right? One is the training group and the other is the testing group. And the training group is basically used to teach the model, like it teaches the model, uh, it gives the model both the input and the output, right? It gives the model pairs of inputs and outputs. It gives the model the input, and it tells the model this should be the output, and that's how it's training the model. For example, over here, it's telling the model that if the sepal length is 5 centimeter, if the sepal length is 3.5 centimeter, and if the petal length is so and so, and if the petal width is so and so, the species should be this. So it's giving both the input, the output, and it's giving both, and it's training the model. That's how it's training the model basically, right? And the training set, sorry, the testing set is used to test if the model is giving the correct output or not. And that's the reason we have to first split the data set into both training and testing sets. So for example, in the iris flower data set, right? So what you're going to do, you're going to take two variables. One is your x. X is always going to be your inputs. And the other is your y. Y is going to be your outputs. So in the inputs, you're going to delete the species column, because the species column is going to go to your output. The species column is basically your output. That's the output you're supposed to get. So you're going to give all the inputs in the x variable, and you're going to give the output in the y variable. So as you can see, these are all your inputs, and your y variable is your output. So you're going to min-max scale both of them separately. And then here is how you split it. You have a separate function to split the data set into train and testing data sets from the scikit library itself. So you don't need to do it on your own. So here you have the x train, x test, y train, y test is equal to train test split function. The train test split function is a predefined function that's already there in your scikit-learn library, right? So you just, these are your variables that you're giving now: x train, x test, y train, y test. These are new variables you're providing now, and you're telling the function this is how you're going to split it, your x, y, and your test size and your random state. As you can see, your x train has 105 columns, and your y test is 45 columns. That's how it's split each of them. And let's see the same thing in your other data set. So in this data set, you're dropping the target from your x because x is going to be your input, and your target is nothing but your salary, right, which is less than equal to 50K or greater than 50K. There are only two values. So that's the reason there's only 0 and 1. It's given 0 for less than equal to 50K. Your label encoder, it has given both of these values a different numerical value. Like less than equal to 50K is it's given 0, and greater than 50K it's 1. So that's what you're seeing here. And your target is basically going to be your output, and which is y, and x is your input. That's why you're dropping the target, or basically deleting the entire column of target from x. So x, you can see there's no target here, and you're going to min max scale each of these. Basically you're reducing the scale of the minimum and maximum values. And as you can see, again, when you're splitting using the train test split, right, your x train has 21,000 rows and the rest is in your x test. And just like that, the equivalent, outputs, whatever outputs you have to get, again, that's there in the y train and in the y test. And then next, what you have to do is you have to choose a model. Now, this is a very crucial step, as you know, the model you choose depends on what data set you're using, because the same model might have different errors. It can give different it can have different accuracy levels in for different data sets. For example, there are many algorithms. We have something called decision trees and random forest. And then we have support vector machines. Support vector machines are basically used for it can be used for classification models, it can be used for regression models, spam detection, handwriting identification, many more. And then you have neural networks. Neural networks, you don't really need to know much now, as it comes under deep learning. We can focus more on a basic machine learning model, something like decision trees and random forest. So basically, like how you saw in this, you have your model comes up with a tree-like structure, right? Here you can see they're branching out, yes and no, again yes and no, and these last whatever predicted price you have, these are called your leaf nodes. So basically it's coming up with something like a tree kind of like structure, and that's the reason it's called decision trees, right? And these each of these trees, they focus on a single feature, and based on that single feature they give you your outputs. So what are random forest is? Random forest is nothing but multiple decision trees together. What it does is it takes multiple trees, takes the outputs of all these trees, gets the average of these trees, and gives you the output. So random forest is nothing but a collection of decision trees, right? So here, okay. And all these models you can find in the scikit-learn library itself. So here we are using decision trees, right? On both our data sets. So first, this is the again the iris flower data set. In the flower data set, what happens? You first import the tree. You first import the tree, right? And then you assign a variable to it so that you can use the decision tree. And then you fit whatever the training models you had, right? You fit it into the D tree model. Your D tree is nothing but your model here, and you're going to fit the training, whatever sets you had, into the decision tree. And this is the function you're going to use. D tree is basically your model, the variable for your model, dot fit. Fit is your function. And X train and your Y train are basically your inputs, the training inputs and your training outputs. So you're giving the output and you're telling this is the specific, you're giving the inputs and you're telling the model this is the specific outputs I'm supposed to get. And your Y prediction is now how you're going to test whether your model is working properly or not. So in your Y prediction, what you're going to do, you're going to have d tree dot predict. Predict is basically going to use your X test. X test was your testing inputs, the inputs that you're going to use to test whether your model is correct or not. Like in the beginning, we had split the data set right into two, one for training and one for testing. This is where you're going to use your testing inputs. So you're going to uh, give your testing inputs into the prediction function, and you're going to have a separate variable for that, y underscore predict. In this you can give any variable, it's fine. And then to check your accuracy, right, whether how accurate your model is working, like how close is it to the actual values, if it's working, if it's giving the right values and all of that. You have multiple evaluation metrics for that. You have the accuracy score, the recall score, the F1 score, precision score, confusion matrix. And what these do is they give you the percentage of how accurate your score is, like how accurately your model has predicted. And it should be, and you should make sure it's as close to 1 as the values range from 0 to 1. You should make sure it's as close to 1. And here the accuracy score, all you have to do is give the accuracy score, like the function name, and you have to put your testing data, the output test, like the one you had split in the beginning, the test data that you had kept separately, the output test, and the prediction that you predicted just now. Y prediction and your Y test, you give both of them in the function as parameters. and you check the score. Here, the one it's given the output as 1, which is the highest you can get, and even the recall score, precision score, FL score, they're all 1, right? You have to make sure all your scores are as close to 1 as possible. And once decision tree is done, again you have the random forest, which is again the same thing. You import the random forest, and then you give it a different a variable, a model variable. And here your n estimators is nothing but how many, like in the beginning I told, right? Random forest is nothing but a collection of different decision trees. And it's going to take the values of all these decision trees, and it's going to come up with an average and give you that value. And n estimators is nothing but the number of decision trees you're going to give in your random forest, like how many trees you want in your random forest. And again, you're going to fit the same, what you did above for the distant tree, you're going to do the same thing again. Your training values, your training inputs and your training outputs, you're going to fit it into the model. And then you're going to have another prediction variable. We're going to give the parameter as the testing variable, and you're going to get the predicted outputs. And again, as you can see, all your scores are 1. But when you take the same uh, model for another data set, like for example, for this data set that we had, we are importing decision tree, and again we are fitting the training data sets, the input and the output. And this is for the salary predictor, right? That was for the flower predictor, which species flower, and here we have the salary predictor. And what's happening here is, as you can see, the accuracy score here, the precision score, the accuracy score is a little different. It's a little less than 1. Here you can see it's 0.8, and the recall score is 0.6. The precision score is 0.6 again over here. And even in the random forest, you have the accuracy score as 0.6, the precision score as 0.7, and so on. So one model that worked for one data set might not work the same for another data set. So it's very important you choose which algorithm, machine learning algorithm you're going to use. And it depends completely on the data set and on you. You can actually just fit your data sets into multiple models, and you can compare and you can see which is best. You can see the accuracy scores, you can see the precision scores, and you can with that you can conclude which model you want to use at the end of the day. Now once the oh sorry and once the models are done, and you're done evaluating and everything, right, the next step is to deploy the model. So these models can be deployed in real world, in like a website or an app, and it can be continuously monitoring and continuously updating itself, and helping people. And deploying the model, we are not going to do it yet. We'll be doing it in the next workshop. Next, you have a certain Other things you need to keep in mind: overfitting and underfitting. So, what happens is, um, in overfitting, it's basically when you give it more information or more features than required, right? For example, like we had the ID column over here, which wasn't really necessary, and it might increase the errors and it might not give accurate results. So this is called overfitting, like too much unwanted data or data which is not accurate, or wrong data when you give it. That's called overfitting. And underfitting is just the opposite of that, where you're not giving enough data to the model. Like, let's say in the same data set, right? Let's say you don't give the petal length or the sepal length. That's underfitting, because you're not giving the model enough data, and at the end of the day it might make the results less accurate. It might increase the error too. Next, we have hyperparameters and epochs. Hyperparameters are parameters are not that are basically given while it's training. For example, in random forest, right? Here, n estimators is basically the number of decision trees, and this is called a hyperparameter. Hyperparameter is something that the user defines, and the user tells while training the model. Another example of hyperparameter is nothing but epochs. Epochs is basically when a model is working, right? Sometimes it'll have to uh, reiterate, in the sense it'll have to train itself again and again and again with the same data but with different parameters, and sometimes a little bit different data. And that iterations, right, that loops is called epochs. Epochs are nothing but each time an entire data set goes through the training model, that is one epoch. Every single time a data set goes through the model completely. So these are important terms you're supposed to know when you're learning machine learning: hyperparameters, epochs, overfitting, underfitting. And now let's come to TensorFlow. Hello guys, is everyone there?
Yeah, Likita, we're here
Doing
only.
well.
Yeah, Nikita, we are.
Are there any doubts? Anybody?
I think Likita, you can take the names and you can ask if they have any doubt or not.
Mm, Aditya, Rajiv, Prajwal, you guys have any doubts? I hope you all are listening.
So today's part is over or anything is
No, just a little more.
okay,
I'll
okay,
finish it fast.
okay, okay. Then you can continue as we are live on YouTube also. That's why.
Okay, okay, okay. So now moving on to TensorFlow, right? What is TensorFlow? TensorFlow is basically a library or a framework that was developed by the Google team, and it helps you develop and deploy machine learning models, especially deep learning models. TensorFlow helps you with mostly everything related to machine learning, but mainly it helps you with deep learning models, right? And it provides you with necessary tools and extra tools, whichever you need, that will make it easier for you to build your machine learning models. It basically really helps you with everything, but specifically it helps you with deep learning models, right? And these are your key features. And it also has an API called Keras, which really helps you with neural networks and deep learning, which we'll be looking into in the next workshop. And you also have something called tensor board, which helps you in visualization to help you understand better, your data sets better, and all your plots and graphs. It helps you with that. It also helps you with deployment. It makes deploying your models easier, and it helps you and it gives you necessary functions and tools for that. And it also has many other APIs, and let me just go through the basics of TensorFlow for you. So in TensorFlow, you have something called tensors. Tensors are nothing but your arrays, your multi-dimensional arrays, right? And it has many functions. I'll just go through all the basic functions that TensorFlow has. Your x dot shape gives you the shape of your array, like how many rows and columns you have. And then your x dot data type, d type, gives you the data type of that tensor. And you can also have, perform certain mathematical operations on tensors. For example, here you can add, there's multiplication, there's addition, you can transpose, you can even concat. Here it's just, adding all the three, adding the x tensor three times row wise. And here it gives the sum. There's also another very nice feature in TensorFlow. It can even access your, hardware, and it can tell you whether you're using your hardware or whether you want to use your hardware. Like for example, here in the physical devices, when you're using, it's going to tell you whether you're using your GPU or not. I don't have a GPU, so obviously it's going to give. TensorFlow is not using the GPU. And another thing you need to remember is the tensors, right? They're immutable. Basically, immutable means you can't really change the values. And then you have automatic differentiation, like you have functions that return the differentiated value. It basically acts like your NumPy library. It gives you the derivatives, the differentiation values, and it just makes everything easier. As you can see here, now we are going to just see how we are going to use TensorFlow, right? Just an example, just a small example. Here you have a function f of x, and this is your y. So here it's plotting, it's basically, we don't have a particular data set, so we are going to take one x value and the corresponding function of that x, which is your y, and you're going to plot all of this, all of the values here. And we are going to randomly generate few values around that. And we are also going to use those values, and we are going to train it in the model. We're going to generate our own values, and we're going to train it. And here you can see that before training, here you have the data values, and this is the prediction. You haven't really trained it yet, like you're giving random values, and that's how it's going to give. Now this is where you're going to train your values, right? Your MSE loss is nothing but your mean squared error. MSE is your mean squared error, where it takes your predicted value and your actual value, the difference between the two values, and it's going to square it, and that's your mean square error. So as long as that is less, your accuracy becomes more. As you can see here, here this is the, I'm not going to get into the code right now. I'll just briefly just go over it. And as you can see here, the mean square error, it was at 54, and it's reducing as it goes on. And you should make sure your mean square error is as less as possible. So here we are taking a training loop, and we are setting the training parameters, right? Here again you have the epoch. Your epoch is nothing but how many training loops it's going to go through, how many times it's going to train itself. So here it's going to train itself 100 times. And your batch size is nothing but how many data sets is going to go through each epoch. So in each epoch you're going to have 32 sets of data going through it. So once you train your data, you can see that your predictions are as close to the your data and the actual values as close as possible, and even your mean square error is, by the time it finishes all the epochs, you can see that it's reduced to almost 1. And what you're seeing here, step 0, step 10, step 20, step 30, all of these are your epochs. Basically, we have given 100 epochs, right? 100 iterations. So at the 0th iteration, it's so much. At the 10th iteration, it's so much. At the 20th iteration, it's so much. And at 90, it's so much. And 100, it's not really given. So by the end of it, you can see that your predictions are very close to the ground truth, and even your mean error is less. So your model is pretty accurate. And there are many other functions and models and in TensorFlow that I'll be doing in the next workshop. Now, I think I'll end it here. Maybe I was, and we'll be even doing a few, hands-on. Like we'll be doing a project. either a classification or a neural network. If you guys want any particular model that you want me to do, you can just tell it. And yeah, I guess that's it for today. Thank you guys.
Yeah, Likita, it was a great session, I think. And as might be we don't have got many number of participants today, but we have kept it in live, and those who it can be used in future also for students who want to access it. So yeah, so for today we are closing, and yeah, next session will be a hands-on session. The Likita will be like directly telling that how to create a project on TensorFlow. I think I am sure, Likita.
Yes, yes, yes.
Okay. So yeah, the next date for the ML session will be giving that dates, and then tomorrow we have a Flutter workshop, same as like today. So yeah, stay tuned for that Flutter workshop. So bye. Okay, thank you guys. Thank you for joining today. Thank you, Likita, again for the session.